Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we are going to be going through the 6 exponential laws that you guys need to know to help you solve your exponential equations. So let's get started. So let's start off by just explaining what an exponent of a number is. An exponent of a number tells you how many times you need to multiply, right, the base by itself, right? So what do I mean by this? As you guys can see on the board, I've got a to the power of n, right? A is the base and n is the exponent, right? So what this means is that I need to multiply a n times. All right, so a needs to be multiplied n times. But I mean, this might be confusing because if we're talking letters, that might confuse someone, that might confuse someone. So what does this mean if I were to actually put real numbers and explain it using that? Okay, let's have a look. So like I've mentioned, right, the 7 will be the base and the 2 will be the exponent. And the exponent basically tells us how many times we need to write out that 7, right? How many times we need to write out that 7. So how many times would we need to write out the 7? We'd need to write out the 7 2 times, right? So let's write that down. Okay. So 7 raised to the power of 2 is equal to 7 times 7. All right, so that's what it means. Let me give you guys another example. 8 to the power of 4, right? The exponent 4 means that we need to write out 8 4 times, right? So it's 8 times 8 times 8 times 8. We need to write it out 4 times, right? So it's going to be 8 times 8 times 8 times 8, right? So that's what an exponent of a number means. Okay, so now let's get to the exponential laws that you guys need to understand and obviously know by heart to help you solve your exponential equations. Let's get started. All right, so let us actually go through the first exponential law that you guys need to know, right? So what you can see on the board, we've got a to the power of n multiplied by a to the power of m, right? So this law says if you have 2 powers, right, with the same bases, right? So that base is a and that base is also a, right? Then you add your exponents. So if you're multiplying 2 powers that have the same base, then you add your exponents. Okay, that is the first exponential law. Okay, so how would you write this out? Okay, so a to the power of n multiplied by a to the power of m is equal to a all raised to the power n plus m, right? Because you've got 2 powers that have got the same base, right? And you just add your exponents, okay? So that is the first exponential law. Let's have a look at the second exponential law. All right, so with the second exponential law, right, the second exponential law, what can we see here? We see that we are dividing and we are not multiplying, right? So if you are dividing 2 powers that have the same base, right? So that is a, right? And then you are dividing by these 2 powers, then you subtract your exponent. So all you're going to do is you're going to take this a, right? And then you're going to take the n that's at the top and you're going to minus the denominator exponent, right? So if you have 2 powers and you are dividing them, then you are going to subtract the exponents. So you're going to take the base, which is a, and you are going to subtract the exponents, which is n minus m. All right, let's have a look at the third exponential law. We've got a times b all raised to the power of n. So everything that is inside this bracket is raised to the power of n, is raised to the exponent n, right? So what does this mean? So this means that the a is raised to the power of n and multiplied by the b, which is also raised to the power of n, right? So with the third exponential law, right, if you've got two numbers that are in a bracket and they are all raised to an exponent, then those numbers can be individually raised to that exponent, meaning that a is raised to the power of n and the b is also raised to the power of n. All right, let's look at the fourth exponential law. All right, so this fourth exponential law, we can see that we have a over b, right? So a over b, and this whole fraction is raised to the power of n, right? So what does this mean, right? A over b all raised to the power of n, right? So what does this mean? It means still that the a will be raised to the power of n and the b will also be raised to the power of n, right? So let me show you what this means. This means that this can also be written as a all raised to the power of n divided by b all raised to the power of n. Let's look at the fifth exponential law. All right, so with the fifth exponential law, guys, we see that we've got a to the power of m all raised to the power of n, right? So everything that is in this bracket is raised to the power of n, right? So how can we rewrite this, right? So this fifth exponential law says that if you've got a to the power of m all raised to another exponent n, this basically means that you can also write it as m. You multiply these two exponents together, right? So you're going to have m multiplied by n, right? A to the power of m times n. Okay, and let us look at this last exponential law. All right, so the sixth exponential law states that to find the root of a power, you divide your exponents, right? So we can see that we've got a root here, and obviously we've got a power. We've got a raised to the power of m, and this exponential law says that to find a root of a power, you simply divide your exponents, right? So how would you write this out? You take your a, right, all raised to the power of m divided by that n there. Divided by n there, right? So this root of this power can also be written as a to the power of m over n. So that is our sixth exponential law that you guys need to understand to help you solve your exponential equations, right? There's another one that I also just would like to highlight for you guys so that you guys also understand how it means, so that when you are given an exponential equation that has a negative exponent, how you can work with that to solve your equation, right? Let's just have a look at that. All right, so I'll call this the seventh exponential law that you guys also need to remember when working with exponents, right? So with the seventh exponential law, what we can see here is that we've got a negative exponent, right? So when we have a negative exponent, what do we do? Okay, how can we simplify that to help us answer our questions, right? So a to the power of negative n is also equal to 1 over a to the power of n, right? So a negative exponent is the same as a positive exponent that is in the denominator, right? So we've seen that we've put a 1, and now this a to the power of n has moved, right, to the denominator, right? So a negative exponent is the same as a positive exponent that is in the denominator. Right, guys? So those are the 7 important exponential laws that you guys need to remember when working with exponential equations, right? All right. So guys, those are the 7 important exponential laws that you guys need to know off by heart to help you solve your exponential equations, right? So I'm going to take you through those laws again. The first law that we had is that if you have if you are multiplying by 2 powers that have the same base, you add your exponents, right? The second one, if you are dividing by powers that have the same base, you subtract your exponent. The third one, okay, if you have 2 variables a and b all raised to the exponent n, that means that the a is raised to the exponent n and the b is also raised to the exponent n, right? And then if you are dividing by 2 variables, a divided by b, all raised to an exponent n, same thing. The a is raised to the exponent n, the b is raised to the exponent n, right? So it's going to be a raised to the power of n divided by b to the power of n, right? And the 5th exponential law that I took you guys through is if you've got a to the power of m all raised to the power of n, then you just take your power a to the power of m multiplied by the n. So it's going to be a all raised to the power of m multiplied by n. And the last one that I took you guys through is that if you are taking the root of a power, right? A root of a power, then you're going to take that power, a to the power of m, and you divide the exponents, right? You take the a, you take the number that's inside the root, which is the base that is inside the root, and you divide by the exponent, which is going to be the m over the n, right? And the last one is that if you have a negative exponent, you can rewrite that negative exponent as a 1 over a positive denominator. So it's 1 over a positive a to the power of n and not negative n, right? So those are the 7 important exponential rules that you guys need to remember to help you solve your exponential equations, right? So now let's put these rules into practice. Let us actually start solving exponential equations and applying these rules. All right, guys, so now we're about to simplify 8 exponential equations, right, using the exponential laws that I have basically explained to you guys, right? So at this instance, I'm going to put the exponential questions here. Please just pause the video, write down the questions, try them on your own and see if you really understood all the laws that I was going through with you guys. And then from there, guys, play the video to see if you understood all the concepts, right? So that's how you are going to see where you lost me or where you didn't understand, right? Okay, so let's get started. So let's have a look. We've got 2 to the power of 3x multiplied by 2 to the power of 4x, right? So here we've got product. We have a product of 2 powers that have the same base, and we've said that if you have same bases, what do you do with the exponents? You add the exponents. So we are simply going to do that, right? So we've got the same base, we've got a 2 here, and we also have a 2 here, right? So we are simply going to add our exponents, right? So we're going to rewrite the base, and we're going to say 3x plus 4x, okay? Which is going to be equal to 2 to the power of 7x, okay? Alright, for question 2, we've got 4x to the power of 3 all over 2x to the power of 5, right? So here we do see that we do have the same bases here because we've got an x there and we also have an x there. So we can just simply subtract these exponents from each other using the quotient rule. Alright, and another thing that we also see here is that we have coefficients, right? In front of our bases, right? So we've got a 4 and we have a 2 there. So we can also simplify those to get to our answer, right? So I'm going to first write it out. So I'm going to show you guys 2 methods that you can solve this equation. Okay, and I'm going to divide these 2 methods by a line so that you see, right? And work with the one which you feel comfortable with, right? So we're going to start off with method 1. Okay, so this first method, I'm just going to break down the numerator and I'm going to break down the denominator and cancel out the values that you have at the top and the bottom to get our final answer. And with the second method, we are going to use the quotient rule, where you see that you've got the same bases and you subtract your exponents, and you also just simplify your coefficients. Okay, so let's start off with the first method. Okay, so the 4 can be written as a 2 multiplied by the 2, right? And the x cubed can be written as x times x times x, right? Okay, all over. Okay, we can rewrite that 2 at the bottom, right? And then x to the power of 5 can be written as x times x times x. So we're going to write out our x 5 times. So from here, we can simply cancel out the values that appear at the top and at the bottom. Okay, so we've got the 2 at the top there. We've got a 2 at the top. There's a 2 there, so we can cancel. We've got an x there. We've got an x there. We can cancel. Another x there. We've got another x there. We can cancel. Another x. Okay, so now we can just simply write down what we have left. So what we have left at the top is the 2. So we're going to write it down. And what we have at the bottom, okay, what we have left at the bottom is that, okay, how many x's do we have? We've got 2, right? So our answer is 2 all over x squared. Okay, so that's the first method that we can use. Okay, the second method that you guys can use is you're going to deal with your coefficients first, and then you're going to deal with your bases. So let's deal with our coefficients. So with our coefficients, how many times does 2 go into itself? 2 goes into itself how many times? Once. Okay, and how many times does 2 go into 4? 2 goes into 4 2 times. Okay, and then now let us deal with the bases, right? So with the quotient rule, it says that if you have the same bases, what happens to the exponent? You need to subtract the exponents, right? So we're going to rewrite our base, which is x. Okay, and we're going to subtract our exponents. So 3 minus 5. And what is our answer? So I'm not going to write that 1 anymore. So it's going to be 2. 3 minus 5 is minus 2. Okay, and guys, I already mentioned that if you have a negative exponent, that base with the negative exponent can be moved, or the power with the negative exponent can be moved to the denominator, and it becomes a positive. So those are the two methods that you can use to help you solve this, depending on whichever one. So you need to choose which one you're comfortable with, right? So the first one is when you just cancel, and the second one is when you just deal with your coefficients first, and then you look at the base. With the bases, you're applying the quotient rule for your exponential equation, your quotient rule for exponential equations, that states that if you're dividing by powers, then powers, that means that you subtract your exponents, which is what you did here. So it's 3 minus 5, which is minus 2, and we got our answer to be 2 over x to the power of 2. Okay, let's look at question 3. So we can also apply, I'm going to use the two methods to show you guys how you can solve this question, right? Okay, so the first one is just writing it out. Okay, so how can you write out the 12? We can write out the 12 as 4 times 3. So 4 times 3 is equal to 12. So I'm going to write that down, right? So 4 times 3 is equal to 12, right? Multiply. We've got two p's, right? So it's p to the power of 2. So it means that we need to write out our p 2 times. So it's p multiplied by p. And we've got t to the power of 5. So that means that we need to write out our t 5 times. So I'm going to say times all over, right? We can't further break down our 3. So we'll just leave that as the 3, right? And then we've got 1p, so we're going to have the p there, multiplied by how many t's do we have? We've got 3 t's, so we're going to write that out t 3 times. So it's t times t times t, right? And from here, guys, you can just simply cancel out, right? We're going to use our cancelling. So now let us check and see what we are left with. Okay, what are we left with in our numerator? We are left with the 4. I'm going to circle what we left with. It's the 4, it's the p, and the 2 t's, right? So that's what we're going to write. So it's p and t to the power of 2, right? And what are we left with at the bottom? We're left with nothing, right? So guys, that is our final answer. Okay, so if you don't like this method, you can also use this method, where you're going to say equal to, right? Okay, we're going to first start off by dealing with our coefficients. So our coefficients of our base is the 12 and the 3. Okay, 3 goes into itself how many times? 3 goes into itself once. So I'm going to put that 1 there. 3 goes into 12 how many times? 3 goes into 12 4 times. So the 3, 6, 9, 12. So it goes into 12 4 times, right? Okay, and then we're going to apply the exponential law that tells us that if you are dividing by powers, right? So we've got p squared times t to the power of 5 divided by p times t to the power of 3. That means that you need to subtract your exponents, right? P 2 minus 1 is p, right? Because it's going to be p to the power of 1. And then 5 minus 3 is 2. So it's t to the power of 2. Okay, and that is your answer. Okay, so we get to the same answer. So it just depends on which method you prefer using. Okay, guys. Alright, so we've got 3x all raised to the power of 2. So this is the same as saying 3 all raised to the power of 2 multiplied by x all raised to the power of 2, right? And I said that 3 to the power of 2, that exponential 2 means that we need to write the 3 2 times. So it's going to be 3 times 3 times x to the power of 2. And then 3 times 3 is equal to 9. And then x to the power of 2. Okay, so we have simplified this, and that is your answer, 9x squared. Let's move on to question 5. We've got 3 to the power of 4 times 5 to the power of 2, all raised to the power of 3. Like I mentioned, you are going to apply this exponent. Okay, we're going to apply this exponent to that and to that, right? So we can say it's going to be 3 to the power of 4 times 3, okay, multiplied by 5 to the power of 2 times 3. Okay, we're going to simplify that further. 3 to the power of 4 times 3. 4 times 3 is equal to 12. So it's 3 to the power of 12 multiplied by 2 times 3 is 6, right? Number 6, okay, we've got 6p to the power of 0 multiplied by 7p all raised to the power of 0. What does this mean? Anything to the power of 0 is 1, okay, multiplied by, we need to put everything that's within this bracket needs to be raised to the power of 0, right? So times it by 7 to the power of 0 multiplied by p to the power of 0. Okay, so I'm just rewriting everything so you see what's going on. So 6 times 1 is 6 multiplied by anything to the power of 0 is 1 multiplied by 1 multiplied by 1. Therefore, the answer for your number 6 is 6 times 1 is 6. Question 7, 2xp all over 6x squared all raised to the power of 3. What I'm going to do is I'm going to deal with what is inside the bracket first. Okay, so we're going to simplify what is inside the bracket first, and then we're going to raise what's left to the power of 3. Okay, so we're going to just write out the 2x and the p, right, all over 6 can be written as 3 times 2 times x squared is x times x. Okay, or raised to the power of 3, right? So we're just simply going to cancel what we see at the top and at the bottom, right? So we can cancel out the 2's. The 2 and that 2 can cancel. That x and that x can cancel. And let us write down what we are left with, okay? At the top, we are left with the p. And at the bottom, we are left with the 3 and the x, right? So we're going to write that down. P, right? And all of this is raised to the power of 3, right? So with exponential laws that we went through, this 3 says that the p needs to be raised to the 3, the 3 needs to be raised to the 3, and the x needs to be raised to the 3. So I'm going to write that down. So it's p to the power of 3 all over 3 times 3 multiplied by x to the power of 3. Can this be simplified further? Yes, it can. Okay. P to the power of 3 stays as P to the power of 3 all over 3 times 3 to the power of 3 is 27, right? X to the power of 3. Okay, let's look at the other method, right? We said that we want to start with what is inside the bracket first, right? So we've got a 2. Let's deal with the coefficients first. How many times does 2 go into 6? 2 goes into 6 once, right? And goes into itself once and goes into 6 3 times, right? So we're going to put the 3 there, right? And what are we left with at the top, right? We've got the same bases, right? The x and the x there, right? We're going to subtract your exponent, so it's going to be x, okay, to the power of 1 minus the x to the power of 2, okay, multiplied by the p, and all of this is raised to the power of 3, right? So I want to deal with what's inside the bracket first, right? And then you're going to have 1 over 3. 1 minus 2 is minus 1, x to the power of minus 1, and p all raised to the power of 3, okay? And then from here, okay, we know that if you've got a negative exponent, you can just simply move it to the denominator. So you've got 1, so you can just be left with the p at the top, all over 3 times x to the power of 1, right? All over 3. And then you multiply this 3 inside like we did on that side. So you'll be left with p to the power of 3 all over 3 to the power of 3 times x to the power of 3. Okay, and when you simplify this further, you've got p to the power of 3, okay, all over 27 x to the power of 3. Okay, we're done. And the last question, guys, you've got 2 to the power of negative 2, all raised to the power of 2x plus 1. Okay, we're going to start off with what is inside the bracket, which is 2 to the power of negative 2. And we said that if you have a negative exponent, you can move that 2 to the power of negative 2 to the denominator so that it becomes a positive, right? So what do I mean by that? You can simply say 1 over 2 to the power of 2, right? So now it's positive, and everything here is all raised to the power of 2x plus 1. Okay, and then from here, what do we do, guys? Everything that is outside our bracket, okay? So the 1 is raised to the power of 2x plus 1, and the 2 to the power of 2 is also raised to the 2x plus 1. So I'm going to rewrite that. So the 1 all raised to the power of 2x plus 1, right? All over the 2 to the power of 2 all raised to the power of 2x plus 1, right? Let us simplify this further, okay? If you take 1 raised to anything, so if you take 1 and you raise it to the power of 2, you'll always get 1. If you take 1 and you raise it to the power of negative 1, right, you'll always get 1 because it's going to be 1 over 1, which is equal to 1, right? So anything, so 1 raised to the power of anything, right, will always be 1, okay? So we'll have, okay, so the numerator is always going to be a 1 in this case, right? All over, okay? Okay, let's simplify the bottom part, right? And the denominator. We've got 2, right? 2 times 2 is 4x plus 2 times 1 is 2. Okay. Alright, so if you don't want to leave your answer in this form, you can simply take this whole denominator and put it at the top, right? So you can put it at the top, take it to the numerator. And for you to take it into the numerator, what needs to change? The sign of the exponents need to change. So it can be 2 to the power of negative 4x minus 2. Okay, or you can just say 2 to the power of negative 4x plus 2. Okay, so from here we are done. So that is it, guys, on today's video tutorial on exponential laws and solving exponential equations. I hope you guys really enjoyed this video tutorial, and I hope I really made everything really easy for you to understand, because that is what distance learning with Lee is all about. And please make sure that you are subscribed to the channel if you are not already, and please also make sure that you give this video a huge thumbs up so that it reaches more learners that are struggling with mathematics. See you on my next upload. Bye, guys.